All right, lesson 1.2.2, how can I use programs? Programming formulas and experiments. We're going to do one of these formulas, the quadratic formula, onto our graphing calculator. So if you have a graphing calculator from home, you'll now have a formula that will calculate the roots of a quadratic for you. So here we go. Not much out of the book here, so mainly here just paying attention to the calculator, trying to follow along and download this program. So here we go, starting off, program, new. Okay, create a new program. We're going to name it quad form. Okay, so you got to spell that out there. We're going to go Q, U. Okay, enter. Now, we got to think about what we need to know. When you're doing the quadratic formula by hand, what do you got to know? You got to know the coefficient for the x squared, which we call a. We got to know the coefficient for the x, which we call b. We got to know the coefficient, or excuse me, the constant, which is c. So we need to ask whoever's running this program what those values are. So here we go. We're going to go program and input output display. Now anytime you're prompting them and you're asking them a question, you have to put it in quotations. So let's just ask them for a. So let's say input a. Alright. Now when they type in their a value, we need to store it. There's a function for that. It is actually called input. So input a. Notice the difference. This input is all caps. That means it's something that people running the program will see. This input is not. That means it's an actual calculator function. Next, we got to do the same process but for B. So display, ask them for it. Input B, close your quotations, enter. Every time you got to hit enter. Notice how it brings up another colon. That's a different step in the program. Okay, whoops, program. Input, and I want to store that B value. We'll just call it B, it makes it easy. Last, input that constant value. So you should be a pro by now, it's the third one. So input C, quotation. And then I need to store that for myself for later use, input variable C. Okay, now once we have A, B, and C, what do we need to do? Okay, first of all, we're going to have to, the quadratic formula is very big, especially with that square root in there. Plus, there's answers that square root will give us that will yield non-real solutions. Hopefully you know what those numbers are. So we've got to account for that also. So before we go any further, we're going to figure out just what's inside the square root. That's called the discriminant. All right, and we're going to call that, we're going to label it as D, store it as D. So, what's inside the square root of the quadratic formula? B squared minus 4AC. Okay, store that to variable D, our discriminant. Now, we need to ask the calculator, is that D value a positive number? Okay, so let's see here. Program if D is less than, so that's going to be a test. Second test. Okay. If D is less than 0, then we got to tell the calculator what to do. If D is less than 0, we're going to tell it to go to, and then you got to label something, so we're going to just call it 3 for now. And I'll get back to that later, what that means. Okay, now if D is greater than 0, it just skips over all that, which is good, which is what we want. So if D is greater than 0, that means we can actually get answers. So we got to plug in the rest of the quadratic formula here. The opposite of B plus the square root of D. Whoops. Square root of D. Okay. Ooh, my bad. Put that in parentheses. The whole top needs to go in parentheses. Second, insert. We'll insert what you want without typing over. Divided by, parentheses, 2a. Okay, so the opposite of b plus the square root of d divided by 2a. And we're going to store that to a variable. Let's call it whatever you want. I'm going to call it r. Enter. Now there's a second answer, right? So every quadratic has two answers. So we have the opposite of b minus the square root of d Every parenthesis you open, you must also close. Open the parenthesis, the square root opened its own parenthesis, close the square root parenthesis, close the one I opened, divide it by. Yes, the 2a has to be in parentheses. Whoops. The 2a has to be in parentheses itself also, otherwise it would divide by 2, then times by a. And we're going to store that to another variable. You can name it whatever you want. I'm going to name it s. Alright, so I have my two answers. All I got to do is tell the user what the answers are. So I want to display, so program, display. Alright. And then go ahead and say roots equal, whoa, let's see here, R, comma, S. Enter. Okay, now that should work for any real roots. We need to finish what we started with the non-real solutions. So, well, before we go, yeah, let's do that. Okay, so we want to tell the calculator where 3 was. So right there, label 3. That means if it's less than 0, it'll skip everything in between and go straight to line 3, which is right there. And now we want to tell the calculator to display that there are no real solutions. So we would say no real or non-real roots. I guess we could say non would be better. Roots. All right. And we should be good to run our program. So let's quit. All right, program. Select the program we're going to run. They give us a quadratic here in the book to test. 2x squared, 5x, and minus 7. So go ahead and run quad form. Hit enter. Input A, 2. Input B, 5. Input C, negative 7. Look at that. 1 and negative 3.5. Oh, no non-real roots. Wait a second. Why did it all show up at once? That means we have a bug in our calculator, or in our program. We gotta go back and fix it. But did it give us the right x-intercepts? 1 and negative 3.5? Yes. That means all of our work and our math is good. We just have a small programming error. That happens a lot. And you gotta have patience when you're writing a calculator program. And you gotta be able to go back and try to figure out what's wrong. So let's go into it and edit. And where did I go wrong? I went wrong after I displayed my roots. Because once it's done displaying those roots that exist, I want it to stop. I want it to end. So insert, align, okay? So how did I do that? I pushed second, insert, and then hit enter, all right? So what am I going to put there? I'm going to tell the calculator to stop. Now, don't be confused. You could do end, but end is for something different. End is when you have a loop that continuously runs over and over again. We don't have that, all right? So we just want to actually use the word stop, okay? Now, give it a shot. So let's do it again. Program, quad form, enter. Input A, 2. Input B, 5. Input C, negative 7. Look at that. 1 and negative 3.5. Done. Now let's try one that has non-real solutions. Okay, so input A, let's say 1. Input B, let's say 2. And input C, let's say 6. No real roots. Perfect. And we're done for the day. See you on Monday.